If any group is separated by sigma bond, then it is known as conjugation. Then what is the meaning of conjugation? Conjugation means separated by sigma bond. So I classified mainly in cases, different cases when will resonance takes place. In this case, double bond is in conjugation with carbocation. This means there will be a resonance. This type of structure we can draw when equal contribution in hybrid, 50% contribution in hybrid. What is the meaning of that arrow? Movement of, in this case, they are equal stability. This means we can draw hybrid as delta plus, or we can write, in all the example, you have to draw arrow where the electrons are moving. I initially told you that whatever pi bond position you can take, you can start. Hello to everyone. Now in today's lecture, we will learn how to draw different resonating structure and when will resonance takes place. Our focus is mainly based on the how to draw different resonating structures. Now before starting lecture, we should know some basic definition of conjugation. What is the exact meaning of conjugation? Conjugation means double bond or two group is separated by sigma bond. If any group is separated by sigma bond, then it is known as conjugation. It can be double bond, it can be triple bond. If it is separated by sigma bond, then it is known as conjugation. Now let me explain with the help of a simple example. Now in this example, this is a double bond conjugation with double bond because it is separated by sigma bond. Similarly, we can say that double bond conjugation with carbocation because it is separated by sigma bond. Similarly, double bond conjugation with carbanion because it is separated by sigma bond. Then what is the meaning of conjugation? Conjugation means separated by sigma bond. Got it? So you can write in your notes, conjugation means separated by sigma bond. Now identify in which of the following which of the following structure there is a conjugation. Well, you have to identify whether the conjugation takes place or not. Now let me explain example first. In our first example, there is a conjugation, double bond conjugation with double bond because it is separated by sigma bond. In second, double bond not in conjugation because it is separated by two sigma bond. There must be only one sigma bond. Similarly, it is a conjugation, double bond conjugation with double bond separated by sigma bond. Similarly, fourth is a conjugation, double bond conjugation with carbocation separated by sigma bond. Similarly, double bond conjugation with cation. This is not a conjugation because there are two sigma bond. So out of these 5, 1, 3 and 4 has conjugation. Now if I ask one more question, this is conjugated dienes or not? Is this a conjugated dienes? Double bond, sigma bond, double bond. This means it is not a conjugation. One more example. Double bond. Is this a conjugation? This is not a conjugation because in between two pi bond there are more than one sigma bond. This is conjugation because it is separated by sigma bond. So write down all these examples. So there is no conjugation in 6, no conjugation in 7. And one more famous example of conjugation is benzene. In benzene there is a double bond conjugation with double bond conjugation with double bond. This is also a conjugation. Pause the video and write all these examples in your notes. Now this is the most important part of resonance. When will resonance takes place? So I classified mainly in cases, different cases when will resonance takes place. So today's lecture is based on case 1 and heading will be when will resonance takes place. When double bond is in conjugation with carbocation or vacant orbital. If there is a conjugation in between carbocation and vacant orbital, or there is a, you can say, pi bond and vacant orbital. Now in this case, double bond is in conjugation with carbocation. This means there will be a resonance. Now we already know how to draw resonating structure. In resonance we mainly move pi electrons and lone pair. So what we will do, for simplicity, I will write the number of the carbon. If I move pi bond from 2, 3 to 1, 2, this is a delocalization of pi bond. Means delocalization of pi bond means it is a resonance. If I move pi bond from 2, 3 to 1, 2, or we can say 3, 2 to 2, 1, pi bond from this to this. So this means the carbocation will be at third carbon. Because this pi bond when moved from 3, 2 to 1, 2, the valency of first carbon will be satisfied. This carbon become electron deficient, means this become carbocation. So this is a resonating structure. So whenever there is a double bond conjugation with cation, what you have to do? You have to move pi bond from 3, 2 to 1, 2. This is resonance. Now, what about the stability of these two resonating structures? Are they same identical stability or not? Same stability or not? In both case, both RS, these are the resonating structures, they are of equal stability. Now, how we will determine that equal stability? If the structures are identical, exactly same, duplicate, this means they have same energy. This means the hybrid will be, there is a double bond in between 1, 2 and double bond character in between 2, 3. Hybrid can be delta plus, or we can also draw hybrid can be plus half. Equal contribution means the contribution of this is 50% and contribution of this is 50%. Why 50% contribute? Because two RS of equal stability. This means this carbon is positively charged, means contribution in hybrid will be plus half because the contribution of this RS is 50%. Now this carbon is neutral, this means contribution will be 0. So what is the net charge? Net charge will be plus half. Now, let us explain with the help of orbital diagram. There is a pi bond in between 2 and 3 carbon, and the first carbon orbital has carbon vacant p orbital. Now, we move pi bond from 2, 3 to 1, 2. This means the new pi bond formed in between 1 and 2. And where will be the vacant orbital? Vacant orbital will be in the third carbon because the valency of this third carbon is unsatisfied. So if we move pi bond from 3 to 1, 2, then third carbon will be electron deficient. Got it? Now third will be the vacant orbital. So similarly, initially this is the vacant and second RS, this is the vacant. Got it? So draw this in your class notes, pause the video, draw it. Now let us draw one more structures. Example 2. In this case, again double bond conjugation with carbocation. 1, 2 and third carbocation is separated by sigma bond. How to draw resonance? We will move pi bond from 1, 2 to 2, 3. The pi bond move from 1, 2 to 2, 3. This means this carbon become electron deficient, means carbocation will come on first carbon. Now, are these resonating structures are of equal stability? They are not equal because they are different in structures. Different means different in the, you can say they are not exactly identical. Or we can say that this is our 2 degree cation and this is our 1 degree carbocation. Our 2 degree and 1 degree cation have same stability. They have not equal stability. Now, how to draw hybrid? Now, what is the meaning of not equal stability? Means contribution in hybrid will be different. Now, in this case, how to draw resonance hybrid? There will be a delta plus, delta plus. This is correct. Now, if I draw like this, plus half and plus half, this is incorrect. Now, why this is incorrect? These type of structure when we can draw when equal contribution in hybrid, 50% contribution in hybrid. Got it? In case of not equal contribution hybrid, we will simply write delta plus. Now, what is the meaning of this delta plus? This delta plus simply means the positive charge is shared among first and third carbon. Now, draw all these example along with hybrid. Draw the structure and draw pi curved arrow. where the electron are moving. You have to draw structures along with the curved arrow. Pause the video and try this. Now, how to draw arrow in third? Is there a resonance? Yes, there is a resonance. Double bond conjugation with positive charge. We will move pi bond from 1, 2 to 2, 3. This means the positive charge will be on first carbon. Got it? Now there are two RS and this is the resonance hybrid. What is the meaning of that arrow? Movement of pi electron, 2 electrons. Similarly, is there a resonance? Yes, double bond conjugation with positive charge. Now this means we can move pi bond from 1, 2 to 2, 3. You have to simply move pi bond from 1, 2 to 2, 3. This means the positive charge will be on first carbon. How to draw hybrid? There is a resonance hybrid in 1, 2, 3. Double bond character between 1, 2, 3. In this case, they are equal stability. This means we can draw hybrid as delta plus, or we can write plus half in resonance hybrid. Now in example 5th, there is no resonance. Why? Because double bond and carbocation is not in conjugation, because it is separated by sigma bond. Now what happen if I draw resonance? What happen if I move pi bond? Can I move pi bond from this to this? No, it is not possible. Why? Because this carbon become pentavalent. Now you can understand why conjugation is necessary. Conjugation is necessary, double bond conjugation with carbocation. In order to move this pi bond, there must be a vacant orbital, then it can form pi bond. If valency is already satisfied and we are moving pi bond, this means we are extending the valency. Now in case of carbon, we cannot extend valency, means carbon cannot be pentavalent. Got it? That's why conjugation is needed. Now you have to draw all the structure along with the arrow, along with hybrid. Pause the video, draw all structure and draw curved arrow. Now in this case, how many resonating structure are there? If I number all this carbon, the pi bond move from 3, 2 to 1, 2. Or no, not 3, 2, pi bond move from 3, 2 to 1, 3. This means the second carbon become electron deficient. Now again pi bond move from 1, 3 to 1, 2. This means this become electron deficient. Now all 3 resonating structures are there. How many RS will form? There will be 3 resonating structures. Are all the resonating structure are equal stability? Yes, they are equal stability. Equal stability means they exactly identical. Just like we see movies, Judwa, duplicate, just like that. You can see movies exactly duplicate. You can say Salman Khan duplicate. You can say in Judwa, there may be some other character. They are exactly same. In case they are, you can say Tidwa. Teen means Tidwa. Now what is the hybrid? The plus charge is delocalized among 3 carbon. So how to draw hybrid? We can write plus 1 by 3. Now why plus 1 by 3? Because each contributing resonating structure is 33%. This is contributing 1 by 3, this is contributing 1 by 3, this is contributing 1 by 3. 3 RS of equal stability. Got it? Now this carbon is positive charge, means hybrid consists of plus 1 by 3. This is neutral, neutral. In one carbon, neutral, neutral, positive, means hybrid consists of 1 by 3. Similarly, in this case, if you number the pi bond is in 1, 2, then pi bond will go to 2, 3, then pi bond will go to 3, 4, then pi bond will go to 1, 4. Means how many RS are there? 4 RS of equal stability. Now what is the resonance hybrid? Plus half, plus half, plus half, and plus half. 4 RS of equal stability. Got it? So what is the contribution in resonance hybrid? 25%, 25%, and 25%, 25%. And what is the net charge on this resonating structure? Net charge is +2. This means the hybrid must consist of +2 charge. So you can see that plus half, plus half, plus half, all, if you combine all the 4 values, then we got +2. Similarly, in this example, is there is a conjugation? Yes, there is a conjugation. We can move pi bond from 1, 2 to 2, 3 to 1, 2. Third carbon will have positive charge. Then again move this pi bond from 5, 4 to 4, 3. 5, 4 to 4, 3. So there are 3 RS and they are not equal stability because it is 1 degree, it is 2 degree. And what is the resonance hybrid? Double bond character and positive charge in first, third and fifth. Got it? Now let us try these examples. You have to draw curved arrow. In all the example, you have to draw arrow where the electrons are moving. And in this example, there are 7 resonating structure you have to draw. Now in 9th example, the first resonating structure, double bond conjugation with positive charge. I will get positive charge here. Then again move pi bond. This is positive charge. This means the hybrid consists of plus here and plus here. 1, 2 and 3. Got it? And what about 10th? 1, 2, 3, 4, 5, 6, 7. How to draw RS? This will move here. Initially, first carbocation is in first carbon. After resonance, it will go to third carbon. Then next resonance, it will go to fifth carbon. Next resonance, the carbocation will be on 7. When carbocation will be on 7, we will got this resonating structures. 1, 2, 3, 4, 5, 6, 7. Got it? Now after 2, what will happen? After 2, if I move resonance, it will go to 4th carbon. After 7, 2, then 4th, and after 4th, it will go to 6th carbon. You have to draw. Then you will get exactly 7 RS. Now 7 RS of equal stability. You can write delta plus on each carbon, or you can write plus 1 by 7 on each carbon. In 11th, you have to draw 5 RS. Carbon next to benzene is known as benzyl carbocation. Carbon next to benzene is known as benzyl carbocation. Draw 5 RS. Let me explain you resonating structure of benzyl. So let us consider the pi bond in between 1, 2. Or you can take pi bond between 1, 2 or 1, 6. The answer remains same. Now how the answer remains same, I will explain you at the end of the questions, end of the solution. Now first of all, double bond conjugation with positive charge. This means the pi bond will move upward. Now where will be the positive charge? Positive charge will be on second carbon. Again there is a double bond conjugation with positive charge. This means next will be on 4th carbon. Again, you have to move pi bond. Now the positive charge will be on 6th carbon. Again, you have to move pi bond. Now the positive charge on initial carbon. Now, if you compare 1st and 5th resonating structures, are they identical? The 1st and 5th resonating structures, are they identical? I am talking about this and this. Are they identical? They are not identical because of change in position of pi bond. In this example, pi bond between 1, 2 and this example, pi bond between 1, 6. Means they are different. They are not identical, they are different. Now, if I start drawing resonating structure from 1 and 6th carbon, I initially told you that whatever pi bond position you can take, you can start. The answer remains same. Now, how the answer remains same? If I start drawing resonating structure from pi bond between 1, 6, instead of 1, 2, I start with 1, 6. If I start with 1, 6, the same structure will be drawn, then this becomes the last resonating structure. If it is the first RS, this will become last, and if it is the first, this will become last. Means total number of resonating structure will remain same. Now what about the hybrid? Delta plus, delta plus, delta plus and delta plus. This is the resonance hybrid. Got it? Now draw these all. You have to draw all resonating structure. You have to draw curved arrow and hybrid. Draw curved arrow and hybrid. Pause the video and try it. Now in example 2, how to draw? This pi bond will move here, this carbocation will go on this carbon. Got it? Then pi bond will move here, double bond, conjugation, positive charge. The carbocation will be on CS2. And what is the hybrid? There will be delta plus and delta plus. This is the hybrid. And in third example, if I move pi bond, this will be the RS. No need to draw, already drawing. If you move pi bond in from double bond to cation, this is the RS. Again I move this pi bond, this is the RS. There will be 3 RS, and what is the hybrid? Delta plus and delta plus. In 14th, how will you draw 6 RS? You will move pi bond here. This is the first RS, 1. Cation goes to ortho position, second RS. Cation go to para position, third RS. Cation go to again ortho, fourth RS. Then again double bond conjugation with positive charge. Cation go to outside para position, fifth RS. And there will be one more RS, which is the sixth one, when we change the pi bond position. If we change the pi bond position inside the ring, that will be the sixth resonating structure, sixth one. And this will be the hybrid, positive, 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 positive. Now in example 5th, you have to draw 2 RS. Which one 2 RS? And in this you have to draw 5 RS. Draw it. And 5 for this. In all these examples you have to draw RS. One is a very tricky and very important question. If I ask this question whether the resonance takes place or not, majority of will answer there will be no resonance. Now why they will answer in such a way? There is a double bond conjugation with positive charge. If I move pi bond from ring to outside the ring, then what I will get? I will get this structure. Means nitrogen cannot be pentavalent. This resonance is not possible because nitrogen cannot be pentavalent. Just remember, it is the point to remember, nitrogen cannot be pentavalent. Now, why the answer is true? If I ask you, okay, this positive charge is localized or delocalized, then our answer will be, it is localized. It is not participating in resonance. Then how the answer will be true? There is a resonance inside the ring. This pi bond is delocalized. Just like a benzene resonance. So this is a conjugate of aniline. It is known as anilinium ion. These two are resonating structures. So this is a very important question. How many resonating structure for anilinium ion? Answer will be 2 resonating structures. And if they ask in such a way, is this positive charge delocalized? Our answer is it will not delocalize. Or we can also, they can ask in such way also, is there is a resonance in this? There is no resonance because positive charge cannot be, or means nitrogen cannot be pentavalent. Now if I go with phosphorus, phosphorus has vacant d orbital. Phosphorus has vacant d orbital. Now what is the meaning of vacant d orbital? Means it can expand its octet. This pi bond will move here. So what is the resonating structure? This is the RS. Then again pi bond will move. Again we can move pi bond. Again we can move this pi bond. And what is the hybrid? The hybrid of 16 will be double bond, double bond, double bond, delta plus, delta plus, delta plus and delta plus. This is the resonance hybrid. Now in example 17, there will be 5 RS, positive charge 1, 2, third RS, fourth RS, and when we'll move pi bond delocalization of double bond in the ring, that will be a 5th RS. Pause the video and draw all the structures. And highlight the comment that nitrogen cannot be pentavalent. Phosphorus can be pentavalent because it has vacant d orbital. Got it? Now there are 2 examples which you have to draw. Total number of resonating structures. This is X. X is number of resonating structures. And this is Y. And what are X and Y? They are number of resonating structures. RS means resonating structures. So you have to draw and you have to find out what is the value of X and Y. I will explain the answer in next lecture. At the start of the next lecture, first of all, I will explain this, how the answer will be X and Y. So there is a one hint, X is not equal to Y. Got it? One more hint is there, X and Y are not 0. Got it? There will be a DPP also, daily practice problem, that I will give you at the end of the resonance topic. Apart from the lecture, you have to do all the DPPs, you have to do sheet, and after sheet you have to solve my book, the book that Advanced Problem in Organic Chemistry by Balaji Publication, and you can solve that book. But first of all, you have to attend your lecture, you have to solve all DPP. Wherever you are studying, you have to solve that study material of corresponding your coaching, your school, wherever you are studying. After doing all the things, at the end, you have to try our book. Sorry, there is a correction. Both cations are same. So there is a slight change in structure. This is correct. In one carbocation in this carbon, in second structure carbocation will be on next carbon. Okay, rest all remain same. Thank you. Jai Hind.